All right, let's take a look at this thing, right? If we are 204 centimeters from a source, our intensity is 12 watts per square meter. What would be our intensity if we were to move 68 centimeters from the same source? And this is, I have yet to see an x inverse square thing on an IB test. I'm imagining that they're going to throw something like this at us. So let's be able to solve this. Okay. So our first intensity, so our intensity is going to be some constant divided by x squared. I would use an r, but they're using x's, so I'll use an x. Okay. So we could say that 12 watts per square meter is some constant divided by 204 squared. And by the way, I can just use centimeters here because that the fact that I didn't convert to meters could be part of that constant, right? If it bothers you, you can turn that into meters if you want, but it doesn't really matter. Okay, and then if we are 68, so the question is, what's the intensity? This would be, by the way, the same constant over 68 squared, right? And this looks unsolvable because we don't know I and we don't know K, but K is the same thing. So I'll do my favorite approach here, is that I will go this divided by this equals this divided by this. This has to be true, right? If A equals B and C equals D, then it must be true that A over C equals B over D, right? Okay. All right, so let's take a look at this. That's the Murray rule of truthiness. Okay, and then notice that the k's will divide out, and then by the time you do the 1 over, you're going to end up with 68 squared on the top and 204 squared on the bottom. Okay, it's kind of like by the time you climb up on to the floating piece of ice, you'll end up with you on the bottom and the ice on the top. I determined that empirically, and now we can solve this by cross multiplying. So I'm going to go this times this and then divide by this. Okay, so 12 times 204 squared divided by 68 squared. And I get 108. And that's watts per square meter. And that's because this was, of course, watts per square meter, right? Okay. Now, let me just show you one thing, okay? IB tends to, when they give you problems like this, give you even multiples. So did you notice that this is 3 times, if you multiply this by 3, 68 times 3 is, what is it? 204. That's exactly 1/3 of this thing, right? So if we get 3 times closer, does it make sense that we're going to have 9 times the intensity? Is it possible that 9 times 12 is 108? Indeed it is, right? So a lot of times when you get these things, IB is giving you these, if you see the proportionality, you can just do that, right? And why is it 9? Because you're getting closer and it's an inverse square, right? So it's going to get brighter and it's going to get brighter by the square of the number, right? So if you're 3 times closer, it'll be 9 times brighter, okay? And now, we can also sort of back of the envelope this thing, right? Let me just, encourage risky behavior here, right? Okay. Notice we're at 204, but we're going to get to 68 centimeters. It's got to get brighter. And it's going to get brighter by the ratio of those distances squared. So I'm going to do this. Why this? Why not 68 on the top and 204 on the bottom? Well, because that would, if I put 68 on the top, that would make it less intense. And we know it has to be more intense, right? I do the gas laws this way too. I'm sure it'll bother you just as much. All right, so times 204 divided by 68, and we're going to square that. And indeed, this is 108, okay? Remember, the IB test is a timed test. So, you can do time-saving tricks like that. More power to you. No pun intended.